Hey Kipsters, happy Friday. I'm very excited to be crashing sixth grade math to go over a couple lessons with you today and then a little bit next week. So let's dive in. If you haven't already, go ahead and complete your PDN and pause when you are ready to review. Okay, so let's look at question number 1. Answer the questions about how the outlier affects the data. Below are Javion's scores on his last 5 math quizzes. Identify the outlier and then find the mean with and without the outlier. Okay, so if I'm looking at the data right here, I see 5 different numbers, 99, 91, 60, 94, and 95. Looks like he did really well on 4 of these 5 quizzes. He's gotten A's in all these, but there's one outlier right here at a D minus. At a 60 that's really standing out to me. So what I want to do is I want to figure out what the mean or the averages of all of Javion's scores as they are now. And then I also want to figure out what they would have been if he hadn't have gotten that low grade. So first I'm going to find the mean for all of the data. So the first thing I need to do is I need to add up these 5 numbers, 99 plus 91 plus 60 plus 94 plus 95. And when I add those all up, the answer, the total that I'm going to get is 439. Then to find the average of all those added up, I need to take that total, 439, I'm going to type it into that first box there. And I need to divide it by how many numbers there are in the data set. In this case, there are 5 different numbers here, so I'm going to go ahead and divide it by 5. If I go ahead and I do that division workout, either on paper or with my calculator, I'm going to get a mean average of 87.8. So all those test scores added up means that Javion's getting about a B plus right there for the semester. Now I want to figure out, maybe his teacher's super awesome like Mr. Maganat, and maybe he'll drop that lowest grade because it was an off day for some reason. So I want to figure out what the mean is without the outlier. Now what I need to do is I need to add up the numbers without that 60 in it. I could do that 2 ways. I could go ahead and re-add 99 plus 91 plus 94 plus 95, just skipping over the 60. Or I could take the sum that I already have, 439, and subtract the outlier away from it since I know I don't want it in there anymore. 439 minus 60 is going to get me a new sum total of 379. So that 379 is just these 4 numbers added together without that 60 in it. Okay, so my new sum I just found out was 379. So I'm going to take that sum to find the average now and divide it by how many test scores there are. Now I used to be dividing by 5 because there were 5, but remember I just took away that outlier. So instead of dividing by 5, I'm going to divide by 4. And if I go ahead and do that division problem out, 379 divided by 4, my new mean is going to be 94.8. So now this is pretty cool. I need to ask myself, how did the outlier affect the mean? Well, when the outlier was included in my data, I had an 87.8 average. When I took it away, it's 94.8. So that means that the outlier of 60 lowered the average. It brought his average down because that was an outlier that was less than the rest of the data set. Okay, let's dive into some new material for today. Today, we're going to be looking at patterns in data sets that we see. We have done a ton of work on statistics already, and today's lesson is a bit more straightforward. We're going to look at some data displays, histograms, dot plots, and things like that, and use 7th grade level vocabulary in order to explain what we're seeing. These are the 4 vocabulary words that I'm going to ask you to identify in every single data display that we look at today. The first one is peaks. Peaks, kind of like the peak of a mountain, is the highest part of the data display. Gaps are intervals that don't contain any data in it. It's almost like they're empty. Clusters are groups of data points that lie within the same intervals, so they're like clustered together in one group. And symmetry is when one side of the graph looks almost the same as the other. So a line of symmetry, we see it in art, we see it in everyday life. Your face is symmetrical, a leaf is symmetrical. It means if you were to draw a line down the middle, both sides would be like a mirror image of each other. Okay, so let's look at our first example here. This is a dot plot of the length of different fish caught on a fishing trip. So I see that we have one fish that was 5 inches, 3 fish that were 6 inches, and so on and so forth. I'm going to put this on the same page so that it's easier for us. Okay, so the first thing that this is asking me to identify is, are there any peaks in this data? Now, something to let you know right off the bat. For each of these, there could be multiple answers, more than one peak, more than one gap, more than one cluster. Well, symmetry, I guess, is just one. But for peaks, gaps, and clusters, there could be more than one of each, or there could be none at all. Okay, now remember, a peak is that highest point of a data set. And if I'm looking at sort of how this data is laid out, I see that there are 2 peaks, 2 high points. So my answer for peak is I'm going to say that there's a peak at 6 and 12. That's all I have to say. 6 and 12 are the 2 peaks of this data display. Okay, now I'm going to look for gaps. Remember, gaps is when there's a space between or an absence of any data. I definitely see a pretty big gap in this data display. In between 7 and 11, there's no data. So that would be a gap in the data. I can write this 2 ways. I can write it exactly how I just said it, between 7 and 11. Or I can just go straight to where the gap starts and ends, which is 8 to 10. Oh, not 80, that's a lie. Those are 2 acceptable answers, between 7 and 11 or from 8 to 10. Okay, now I'm looking for clusters of data. This is when the data is grouped together in sort of one cluster or one group. And I actually see 2 of them. I see that there's a cluster of data right here, and I see there's another cluster of data right here. So I actually have 2 answers that I need to write in order to get this question correct. My first cluster is from 5 to 7, and my second cluster is from 11 to 14. Okay, I'm good for 3 out of 4. Now I need to think about symmetry. If I were to draw a line pretty much in the middle of this dot plot, do either side look similar? They don't have to be exactly the same, but there does have to be a way that we can look at it and see, okay, if I folded this in half or if there was a mirror down the middle, do they look similar on both sides? And I would say that the answer to this one is yes. And I can elaborate on that a little bit by saying that the right looks close to the same as the left. Okay, so remember, my peaks are my high points in my data. My gaps are where there isn't any. My clusters are the groupings where data falls really close together. And symmetry is thinking, okay, if I drew a line right down the middle, do either side of that line look pretty much the same? Okay, go ahead and move on to practice set 1. This one is a little bit different. It's a histogram, not a dot plot, but it's the same questions that you should be asking yourself. Go ahead and try that on your own. Hit pause on the video and you can play when you're done. Okay, let's look at practice set number 1. Describe any patterns you see in the following histograms. So this histogram is measuring different pumpkin weights. It looks like there's a lot of pumpkins grown. There's about 50 that weigh between 0 and 10 pounds, about 100 that weigh between 11 and 20 pounds, about 200 pumpkins that weigh between 21 and 30 pounds, about 100 pumpkins that weigh between 31 and 40 pounds, and about maybe 75-ish pumpkins that weigh between 41 and 50 pounds. Those are pretty big. Okay, so the first thing I'm looking for to answer is, are there any peaks in my data? Are there any points that are really significantly higher than the rest of the data in the set? I definitely see that there's a peak right in the middle here between 21 and 30 pounds. So I'm gonna go ahead and write that. There's a peak from 21 to 30. You could write pounds if you wanted to, or you could just write 21 to 30. Okay, now I'm looking for, are there any gaps in the data? I'm looking at each of the different sort of selections or categories on the x-axis, and they all have data filled in for them. There really isn't any point in this data set where there's a gap in data or data doesn't exist. So I'm gonna go ahead and write that there is no gap. Okay, clusters. So for clusters, kind of similar to what I just said about gap, the whole thing is a cluster because it's all together. So two possible answers to this could be there aren't really any clusters because there aren't any gaps to make them. Or since everything is pretty close together, I could say that there is a cluster all the way from 0 to 50. So from that first data point 0 right here all the way to 50, they're pretty clustered together. And my last question that I need to ask myself is, does this histogram show symmetry? If I were to draw a line right down the middle right here, would both sides of it look similar? And again, it doesn't have to be exactly the same on both sides, but it does have to show some similarity. And again, in this case, I would say that it does. Yes, it looks about the same on both the left and the right. All right, team, I want you to go ahead and do practice set number 2 and your exit ticket. Please don't hesitate to rewind the video to watch me go through these again if you need to, and definitely scroll back up to your definitions of peaks, gaps, clusters, and symmetry to make sure that you're doing everything correctly. Good luck.